Hi guys, today we are going to talk about lesson 16.3, which is of course distance, speed and time. First of all, what we need to understand about this lesson is that this is a concept that is basic for you for the rest of your lives if you are going to study anything related to physics or mathematics or engineering, because the concept of speed is actually related to the concept of velocity, and that determines how fast can we go or how fast is an object or a vehicle moving. So to determine that, scientists have determined that we are going to always relate distance traveled over time elapsed. That means how much distance we can cover from one point to another and how long it takes us for us to move along that distance. So this is very, very important. You will find it very usual and probably part of your daily lives around 8th or 9th grade when you start learning physics. So right now I'm only going to tell you that speed and velocity are related to the ratio between distance and time. That means the comparison between those two magnitudes, but they're different in terms of meaning and concepts. How is that possible? Well, in Spanish we actually do it as well. Speed we translate it as rapidez, and velocity as velocidad. What is the difference? Well, in physics or in science, speed relates to that measure of how fast an object is, and that's all. We don't actually want to know anything else, okay? But when we want to know the velocity of an object or the velocity of a vehicle, then we want to know how fast it goes, but also in what direction it goes. Later on in life, you will find out how these two are actually two magnitudes that belong to two different sets. But that's for later, okay? I just wanted you to know that that is right there, okay? And then, of course, we have keywords and problems, of course, that you're going to be doing. You're going to find words that allow you to determine you need to find speed. The words are average pace, or that an object travels at a rate between distance and time, of course, okay? Now, in terms of math, how do we relate those three magnitudes? Well, this is a very simple way to see it. If you think about this triangle, we have speed over here, right? And then speed is distance traveled over time. That easy. Now think about distance and think about time, since they are related to speed. And if we know we need to actually find any of the other two magnitudes, we are actually able to find them. This is the formula we had over here, but with words, right? Speed is equal to distance over time. Now, out of this formula, we will actually be able to get distance. If we solve this equation for d, we gotta take the inverse operation here for t, right? So instead of division, we would use multiplication, and so t would be multiplying with s on the side, right? That's why we get distance equals speed times time. Now, if we wanted to know time, how do we get that? Well, think about this formula over here. If we want to get time equals something on the other side, we're just going to take the speed that is multiplying, that is going to be divided on the other side. So time is going to be distance over speed now. So these are the three possible formulas you can be using when you need to find a specific magnitude. So with speed, you're actually able to find any of the three. Speed time or distance. Okay? And of course, if you keep on looking at the triangle, we have speed equals distance over time, but we also have distance equal speed times time, or we have time equals distance over speed. So the triangle a lot of times is very useful for people to remember how to get these three formulas. But either of the two are actually very useful. Okay? Now I'm gonna work with some exercises that you guys had as homework. Others are not, but then sure, we are going to work with a couple that I found interesting. Okay? So here we have distance and we have time, and we need to find speed, of course. So I'm going to use the first one, right? And then speed here, it's going to be distance over time, which is 60 miles. Please don't forget the units, because here is very important for us to keep the units going. And 2.5 hours. So what we need to do there is to actually divide 60 into 2.5. Now we know 2.5 is the divisor, so we need to make it a whole number. And 60 has to actually follow the same rule. So that is 600, sorry. 600 over here. And then I'm going to divide that, right? So 600, it's going to be divided into 25, which is pretty simple because we know we have 4 25s and 100. So if we have 600, that would be 6 times 4, right? That is 24. That's simple for me. Now, if you don't find it as simple, it's fine. You can just go ahead and do 60, and then we know that's 2 times, that's 50. Then that, of course, is going to be 10, and another 0, that's 100. There you go. See? Told you. That is one strategy that helps me a lot with my mental math. So here we're going to have 24, but then we need to keep the units, miles per hour. Why can't we keep both? Because we're talking about speed, and remember, speed is always the ratio between distance and time. So it's actually accurate to get both units in this answer. Okay? Now I'm going to do problem number 10, which also was part of your homework. Let's see. So here, we're gonna have to find distance. So distance times speed times time, or the second formula over here. So I'm gonna do distance equals speed times time. That is 1/4. And then since I have a fraction, I'm gonna say miles per hour. I can actually work it out that way, and it's fine. It's totally fine. Don't worry about it. Now, times 3/4 of an hour, and hour gotta be up. Okay? That allows us to actually see what are the units we need to cancel, because one is up and one is down. And since we have distance, we shouldn't have time units. That's why we cancel those out. Okay? So we know this is going to be, of course, 3 up here and 16 up here, and that is miles. I'm going to do the third one, which is number 12, and I found it very interesting, just because it actually is using different units of length or units of distance. So before you calculate the time, you actually need to make sure your units are always the same. That means you can never use different units. Like if here we had hours, right, and both. But if we had it minutes here and hours here, we should have actually converted first and then find distance. Same here. We have feet and we have miles. So the first thing we need to do is to actually convert this 1 mile to feet, or the opposite. But I'm just gonna do it that way, just because it's easier that way. So I'm going to do it over here. So 1 mile, as you might remember from chapter 8, is actually 5,280 feet. Okay? So with that, we're going to work. Now, that means that is what we are going to be using for the exercise over here. So we have time. And of course, we're going to be using time is distance divided in speed, or the formula over here. So that is distance over a speed, and then that's gonna be, of course, 5,280 over 2.5. I'm just gonna make it decimals. That's probably a little bit easier. But this is feet, and this is feet per second. So we are gonna have seconds here. I'm gonna say sec, so we don't get confused between this S of a speed with this S of seconds, okay? So if you check, we actually need to get, we have a little fraction over here, so we actually need to get a fraction like this. 5,280 feet over 1, so we can have fractions in both parts, and then 2.5 feet over 1 second. That is going to allow us to do outers and inners, right? And so that is gonna take us to, of course, 5,280 feet times second over 2.5 feet, which, and that is actually gonna give us the option to cancel the units for distance and to actually leave the units of time, which are the units we need, right? Now we need to do that division, so I'm just going to erase up here. Hopefully you don't need that anymore. Oh, I totally forgot to write down the answers, but you got them, right? Okay. Here, I remember this one. It was actually 3/16 miles, right? And then this one, it was 24 miles per hour. Okay. So again, we have a decimal divisor, so we're just gonna make it a whole. That is 25, and of course 5,280 has to follow the same rule, so that gets us 52,800, and we're gonna work with that, which is gonna be really easy to do actually. So that is 825 over here. Think about 52, that's 2 times, and we get 50, that is gonna be 2 as a reminder, then the 8 is gonna be 1, that's gonna be 3 as a reminder, then 30 is gonna be 1 again, that's gonna be 5 as a reminder, and 0, that's gonna be 2. That's it. So here, the time, it's going to be 2,112 seconds. Can we convert it to minutes or to hours? Sure, you can definitely do that, okay? Now I'm going to talk about one of the problems in the lesson. Why only one? Well, because the other ones are actually pretty simple to do if you are able to identify what are the magnitudes present and what is the magnitude you need to look for. Okay, so it's all about reading the problem very carefully and probably just write down S, T, and D, and then just write down the values you have and make an question mark in the value you know it's going to be unknown and you need to find. Okay? Now the other problem I want to talk about, it's problem number 15. And that problem is just different because we gotta do conversion of units. The problem says if the average pace a Lilliputian can walk at a rate of 0.2 mile per hour, about how long would it take a Lilliputian to walk the 300 yards from the forest to the sea? And then you have to estimate. We know speed is going to be 0.2 miles per hour, I believe, right? And then they also talk about distance, right? And that is 300 yards. And they ask you how long, so that is time for sure. So here we're gonna have time with the question mark. That means that is what we have to find. But can you see, we have miles and we have yards, so we have to convert the units first. How are we gonna do it? Well, we're just gonna use bi-dimensional analysis as we did before. And since we have time and we have a long distance, I'm also going to convert the hours to minutes. So that is probably easier for us to work. So I'm going to take 0.2 miles over 1 hour, right? That is what this ratio, that is what that ratio means. And then I'm gonna start the conversion. I'm gonna take the miles and I'm gonna make them yards. So for that, I need to remember that 1 mile is 1,760 yards, okay? That is, and I'm gonna do another ratio for going for hours to minutes. So hours gotta go up here, and then I know that is 60 minutes. With that information, we can actually cancel the units we don't need. Oh, oopsie, we do need that one. Sorry. It's hours, the one we need to get rid of. Hours and hours, okay? And if we multiply 0.2 times 1,760, well, I already did it, so this video could be as short as it can be. And so that is going to be 352 yards actually. And then down here, as you can tell, we're going to have 60 minutes. Okay? Yeah, and so that's what we're going to work with. Now, if we divide 352 into 60, we are going to have, and also I also did that, and we're actually going to have, I believe, is about 5.8 about. So I need this symbol over here, and that is going to be yards over minutes. Okay? So remember we had to estimate? So I'm going to estimate so my life is a little bit easier. I'm gonna say this conversion is gonna be 6 yards per minute. Okay? And then I'm going to work with the formula. So I know it's gonna be, again, distance over speed, right? And so my distance is 300 yards. And my speed is actually 6 yards per minute, which is perfect because we know speed has to have a combined unit of measurement. There you go. So here what we're gonna be doing is what we did a minute ago. So we're gonna have 300 yards over 1 over 6 yards over 1 minute. We're just gonna write everything as a fraction, so it makes everything easier to calculate, okay? Just as we used to do it a couple chapters before. And so this is gonna be 300 yards times minute over 6 yards, right? Because we are doing outers and inners again. And we're gonna cancel the yards because we actually need time units, so that's why we get the minutes. And so this is gonna get us into, actually, that is 50 minutes. So we can actually say it is about, because remember we rounded here, we estimated over here, so we had to round here, so this is an estimation. It is about 50 minutes. Is that easy? You don't really have to worry about this lesson if you know how to deal with this, these 3 magnitudes, okay? So I'll see you later for lesson 4. Take care.